Hello, everyone. My name is Shelly Mallard, and this is my Assignment 5 Revisions and Rationale for AP A67 Section BC. Just to recap my unit lesson plan, this unit is for a high school chemistry class involving stoichiometry calculations. So the goal is that students can use mathematical representations to show the quantitative relationship between substances in a reaction. And the objective is that they can solve a variety of stoichiometry problems, including simple mole to mole, mass to mole to mass, and mass to mass units. If I were to determine whether or not the tasks that I give my students provide appropriate evidence of understanding, I'm going to say yes, because they will actually be solving problems. So I'll be looking at their setup. If they have the steps in the correct order with the correct answer, then I know at least problem solving skill wise, they have an understanding of how to work through the problem. Maybe not the deep understanding that I want them to have yet, but we will eventually get there with those units, moles, and grams. Do the task involve a complex real world application? To this, I'm going to answer yes and no. Yes, because we start the unit using a French toast recipe, which includes units that students are already familiar with. They also have a general idea of a recipe that if you were to double the recipe, you can't just double one ingredient, you have to double everything. In the reverse, if you cut it in half, you have to cut everything in half. So the hope is that we can take those units that they're familiar with and turn them into units that are more scientific, like moles and grams. I'm going to say no to this because the example problems that we work through in the gradual release process use reactions they've not physically performed in the lab. So although it might make sense conceptually on paper, they don't know what that looks like real time. But as the unit proceeds, we will be in the lab more often. So they will be able to apply their problem solving skills in a real world situation as our labs progress from very cookie cutter step by step to guided inquiry to more inquiry based, so that students have that opportunity to design an experiment, use their computational thinking to solve problems, which is the IST standard that I reference here. Do I use a variety of assessments? The answer is yes. Simple worksheet after day one, a daily special quiz the following day, just as reinforcement. And for this unit, my final assessment was a drag and drop activity. But again, if this unit progresses beyond the 2 days that we planned for, there would be more worksheets, more practice, there would be more daily specials, there would be lab activities incorporated, and we would end the unit with a final summative exam. Are they given the opportunity to self-assess? I'm going to say this is one place where I probably really need to revise, because no, they are not. But to me, self-assessment reflection could be a simple confidence rating that we take at the end of each day's lesson, like thumbs up, thumbs down. I feel good. I don't feel good. A 1, 3, 5 rating. 1, I don't understand anything that you taught today. 3, I kind of get it depending on the type of stoic problem. And 5, I'm feeling really good about this procedure. Or a simple exit ticket that's going to give them some instant feedback. So again, my ISTE standard, is for students to be able to apply what they know, and no better way to do that is in a hands-on activity in the lab.